Hello, this is Gary. We are going to take a look at outliers in statistics. So I have a spreadsheet here, fill it up a little bit, based on a survey I gave to my statistics and algebra classes this year and last year. I asked them a bunch of questions about things about them and their habits. So I summarized just part of it here. I have a gender of students that responded versus their usual hours of sleep in the night. And I want to look at some summary statistics. So standard summary statistics would be the count, the mean, the standard deviation, and the coefficient of variation. So that's a good start there. That's how it goes. And then the min, Q1, the median, Q3, and the max. And these are two different kinds of summary statistics. So let's show those in, say, like green. So these are percentiles. So they're measured by rank order versus the mean, standard deviation, coefficient of variation. Those are based on kind of adding up the data related to average. Standard deviation, remember, deviation is distance from mean. Standard deviation is an average measure of those distances. So it's just one way to average that, and it's the most popular way. Now, the standard deviation is not really a relevant statistic about the mean. That's why we calculate the coefficient of variation. The coefficient of variation just takes the standard deviation, divides by the mean. So it's a percent spread based on your middle being the mean, and we state that as a percentage. And this way we can compare the spread based on the standard deviation of two different samples. So that's important. So if we want to compare males and females, we would use the coefficient of variation. You can't directly compare two standard deviations unless they have exactly the same mean. Other things to consider. My data here has whole numbers or one decimal point. So in my summary statistics, I want to add those values to two decimals. So let's use that. Let's see, there's that. So it's not down. And notice Sheets was nice enough to notice that since these calculations here were based on standard deviation, when I changed what I was displaying for decimals, they would automatically update those. Usually with percentages, I go to 1 to 2 decimal places. 2 is fine. Anything else you need to adjust? That looks like it there. All right. So what I really want to talk about is outliers. So once I calculate all my basic summary statistics, so those would be the yellow ones here and the green ones here, I then want to start looking for outliers based on that. So the box plot, if you recall, is based on the 5-number summary, these 5 quartiles. And I'm just going to get a picture of a box plot by taking this into StatKey. Sheets does not do box plots. Excel kind of does, but it doesn't do a very good job. It does a vertical box plot, which is more related to like kind of stuff than a horizontal one, which we display related to histogram. So StatKey, search for that, bring it up. We are doing one quantitative variable at the moment, just descriptive statistics. And I can edit the existing data, replace it with my own. I paste it in, ship it, you know. Oh, there it goes. I got a bunch of blank cells for some reason. Bizarro. Okay. Out. Probably won't matter, but alright. Let's see, I do have an identifier column and I have a header row. So okay. So histogram, play around with the number of buckets here. StatKey calculates the summary statistics for me. Box plot. So the way the outliers work with a box plot is we have this interquartile range, and the interquartile range is just the distance across the box. And then we multiply that distance by 1.5, and we extend that distance to the left from Q1, the edge of the box, and Q3, the other edge of the box. Okay, so take this width, multiply 1.5, and reach that extra distance out inside, and see if there's anything outside of that. So when I do the calculations here, I found that my box was 2 units wide, and so I took 1.5 times that width and took it away from Q1. And then I took 1.5 times that width and added it to Q3. And so this tells me if anything is between 3 and 11, that's normal compared to the rest of the data. If anything is outside of 3 and 11, then that's an outlier. So if we look here, the minimum is 3. So is 3 an outlier? It's right on the edge. 10 is the max, that's below 11. So I'm inside the fences. The other way to look for outliers is to use the standard deviation. Now remember, standard deviation is an average distance from the mean. So you have to use the mean. So here I'm calling the mean bar x. Sometimes we call it x bar. Sometimes we just call it mean, something we call it average. So the lower estimate for outliers is the mean minus 2 standard deviations, and the upper one is the mean plus 2 standard deviations. So that puts me with a low of 4.14 and a high of 9.58. And notice the minimum is below this minimum value for outliers, and the maximum is above this maximum for outliers. So although the box plot method says there's no outliers, the standard deviation method says there are. So now I need to explore and look for them. So I probably should sort this data. When you have data that has multiple columns, you need to highlight all relevant columns, including the titles. And then you want to go to your data tab and sort range. Say it's got a header row, and then pick which column you want to sort by, and I'm going to sort from smallest to largest. So 4.14 was the lower boundary, and so notice there was one female that claims on average they get 3 hours a night, so they have an unusually low amount of sleep compared to the rest of the people that did the survey. 9.58 was the for unusual or outliers. It looks like my 10 hours, so the 3 females that slept on average 10 hours a night, they sleep an unusually high amount of hours compared to the rest of the people that follow this survey. So I've identified a few outliers on that method. Let's highlight those. Those are unusually high. And this number is unusually low. So, well, now I have the question, okay, is 3 hours reasonable? Can someone survive on 3 hours of sleep? If I were the doctor, I'd be quite concerned about them. Here we have people that are getting a lot of sleep, and some people need more than others. Ooh. So if some number is way above all the others, then I'd be concerned that these people are very unusual for some reason, or there's an error in the data. I typed it wrong, they typed it wrong. Same thing down here with 3. Maybe on the keyboard we make it at 6, which is right next to 3. So that could be a typo on their part. Who knows? So I can do a little bit of investigation of the outliers here by using these 2 methods for looking for outliers. And then it's more of a qualitative thing that we have to look into with the data if we wanted to investigate further. So that's it for now for outliers. Have a good day. See you later. Figure out how to do this.